Okay, for each of the following, other than empty set, use interval notation to express the set and graph the solution on the number line. Okay, that empty set thing. It is possible, just like when we were solving linear equations, that we would come up with an inconsistent equation that didn't have a solution. Same thing can happen with in linear inequalities. You can come up with something that doesn't have a solution, and if it doesn't have a solution, we would write empty set. Now, will this happen in the homework? I don't know. It won't happen on a test. But it could happen in homework that maybe something doesn't have a solution. Okay, so solving this first guy here, we do all the same steps we would as normal, except if we ever multiply or divide by a negative number, we reverse the direction of inequality. So same steps. First thing I'm going to do is going to distribute there. So I'm going to have 8x plus 3 is greater than 6x plus 3 plus x plus 5. Simplify each sign. So I've got x's over there and constants. So I've got 8x plus 3 is greater than 7x plus 8. Get my x's together. So I have x plus 3 is greater than 8. Go up in here and finish. X plus 3 is greater than 8. Subtract the 3, x greater than 5. And so here I never triggered the having to reverse the direction of the equality. I didn't multiply or divide by a negative number, so I didn't have to do that. Then giving my answer in interval notation. In interval notation, that's going to be the interval from 5 to infinity. Parentheses, because I do not have the or equal to, and the way you indicate greater than forever is infinity. And then the graph, call that 5. So a parenthesis and an arrow pointing to the numbers greater than 5. So there's the first problem. Next one, start the same way. I'm going to distribute. So it's 15 minus 5x is less than or equal to 3x minus 1. Get my x's together. So I'm going to subtract the 3x from both sides. And I get 15 minus 8x is less than negative 1. Subtract the 15 from both sides. Negative 8x is less than negative 16. And then divide both sides by negative 8. And here I get my difference. And it's still there at the top of the screen. If we ever multiply or divide both sides of an inequality by a negative number, you must reverse the direction of the inequality. And so this guy got reversed. We divided by a negative, which then gives me x greater than 2. And so my solution up here, we'll just go up here and write it. Again, x greater than 2. I dropped the or equal to. And you do need to be careful about that. That's not something that if you did it on a test, I would punish you harshly for. But it's a silly little mistake that when you type it into the computer, it's going to get it all. It's going to be marked wrong because you accidentally dropped it. So let's put it back in there. And so it's still or equal. It's still greater than, but now it's or equal to. So a square bracket, 2 to infinity. Greater than is always infinity. The or equal to square bracket. Graph-wise, there's 2. And an arrow pointing to the numbers greater than 2. Let's keep going. Same instructions. Okay, just a little bit longer, but we're going to follow the same thing. Now, a hugely common mistake that lots of people would do, because it feels so good, would be right here. Move that up just a little bit more. Would be right here. Lots of people are going to tell me that's 5 right there. And that is not what we want to do. But it looks, it's trying to lead you into that mistake. Remember, if we do our steps, our first step is distributing. So I'm going to distribute this guy first. And I'm going to remember to distribute that minus sign there. So I have 2/3 x minus 1/2 greater than or equal to 3 plus 2x minus 2 minus x minus 2. Keep simplifying. So over on the right there, we have the x's. And then we have several constant terms. So I've got 2/3 x minus 1/2 is greater than or equal to x minus 1. Okay? Get rid of those fractions. You can try to work it with the fractions in place. That's just like the hardest thing you could possibly do, mathematically. Certainly not the hardest thing in life you'll ever do. But get rid of those fractions. So I'm going to multiply everybody by 6. My common denominator is 6. Cancel. The 3 and the 6 cancel, leaving 2. 2 times 2 is 4. So I have 4x minus the 2 and the 6 cancel, leaving 3. Minus 3 is greater than or equal to 6x minus 6. And it's downhill from here. Let's get those x's together. So subtract 6 from both sides. And I really do like to get my x's on the left here because it makes writing things into interval notation much easier. It is not wrong to have your x's on the right, but if your x is on the right, converting to interval notation is harder to figure out. So I really do like my x's on the left here. And so I get negative 2x minus 3 is greater than or equal to negative 6. Add the 3 to both sides. Negative 2x is greater than or equal to negative 3. And then divide both sides by negative 2. And there's my one big difference that got reversed. We divided by a negative. And so we end up with x less than or equal to 3/2. Interval notation, the way I do less than forever, everything less than 3/2 is negative infinity to 3/2 with the square bracket because it has an or equal to. And graph-wise, there's 3/2, square bracket, and then an arrow pointing to the numbers less than 3/2. I believe in the computer homework all the graphs are multiple choice, but I do not know that for sure. Okay, let's do another one. Just practice, practice, practice. Same instructions, just get it done. So the thing I want to do here is clear the fractions. That would be my first step if I was solving it, if it was an equation. I'm going to clear the fractions. My common denominator is 10. So I'm just going to write this so it's a little bit bigger. And I multiply each fraction by 10. So 10, 10, 10. I don't put a 10, well, you can't see that. I should move that up so you can see it. I multiply each term, each fraction by 10. I do not put a 10 by both the x and the 4. I do not put a 10 by both the 2x and the 1. I put a 10 by the fraction. I put a 10 by the fraction. And a really common mistake is people put 10s all over the place. And you're multiplying each term by 10. Because this is all tied together by that divided by 5, by the over 5, it's considered one term. So I get a single 10. Same thing over here. This is all tied together by the divided by 10, all tied together by the over 10. So it's one term, so I put a single 10 beside it. And then I cancel the 5 and the 10, cancel leaving 2, and that 2 distributes. So I'll get 2x minus 8. Over here, everybody cancels. So less than 2x plus 1. And on the last one, the 2 and the 10 cancel, leaving 5. Distribute. And I get 15. Okay, got some like terms there. And so I get 2x minus 8 less than 2x plus 16. Get my x's together. And we got something weird happening. I've got negative 8 is less than 16. No variables. And a true statement. Negative 8 is less than 16. And so what this means is that the solution is all reals. Or in interval notation, negative infinity to infinity. Now on the flip side, and I don't have an example for it, but you'll just have to kind of remember, and I'll write it down. If it were no variables and a false statement, that would mean no solution, or what mathematicians sometimes use as the empty set. So no variables and a true statement, all real numbers, or negative infinity to infinity. False, no variables, false statement, no solution. And I guess if we had to graph this, let's just call that 0, the graph would just be a line going both ways. Okay, that's a good point to end this video.